start here. Welcome everybody to an exciting presentation of ExactFlat from Javelin. So ExactFlat is an add-on product to SolidWorks that Javelin is very proud to be offering, helping us transition to offer more tools for the textiles market, or really anything that requires flattening. But the biggest market we've been serving is really anything that requires patterns. So textiles that need to be flattened and need to create patterns, seam allowances, all that great stuff, and send it out to the cutter. So we're going to go through just a couple slides to kick it off, and you are going to see a live demonstration of the product in action, and very excited to share that with you. So let's kick it off with a couple slides. You know, just for those of you who are not familiar with Javelin, just a little bit about us. We are the leading Canadian SolidWorks reseller. A year ago, we went through a little bit of a transition where we expanded and acquired a Western reseller, the most popular one out there. So we now offer offices across Canada, 6 offices in total. We have about 70 employees, which is really great because we get to offer these solutions across the country and get to learn from one area and help out other areas right in Canada. About 3,500 customers in total, really all over the map with the type of industry and type of work that they do. Lots of great customers that do require and design with soft materials. So, you know, Technion, an example, in seating. Lots of other furniture customers. Lots of companies that do inflatables or different work, or work with technical fabrics and need to do design work. And this is just a solution that they've really been asking for. So we're really happy to bring it on board. Lots of work that we've been doing with schools. We've been involved with about 125 different schools from coast to coast. So really great to see customers or students coming out of universities and colleges with great education on SolidWorks. And the great thing is once you know SolidWorks, you can pick up ExactFlat in literally hours. It's so easy to start using. I just went through, in the last couple months, went through the learning process myself, and it literally did not take me long at all to get some good stuff produced. When it comes to the actual ExactFlat product, you know, just in a nutshell, before I tee it over to ExactFlat, really it's about the entire path right from a 3D CAD file and getting it out to the cutter for manufacturing. So helps with the design process, advanced algorithms to help with the flattening process to make sure you have the right material lengths, helping with the pattern creation with seam allowances and all that other great stuff. And then can go right to nesting and costing and even documenting the sewing patterns and how that stuff needs to be assembled together. So it really is a complete end-to-end solution that has helped a number of different industries, you know, a few screenshots above, furniture industry, technical fabrics, carbon fiber or other types of fibers, inflatables, inflatable boats, inflatable structures, marine, you know, you name it. You know, really more and more nowadays, it's and the soft materials are an important part of the design. So so it's very exciting to be able to offer that here. So with that, I'm going to tee it over to ExactFlat, and I'm still going to have them take the lead on the technical presentation. So I'm going to bring it over to introduce you to Keith from ExactFlat. I think it is Keith. I'm sending it over to you there, right?
That's correct, yes.
Okay.
Thank you, Eric. Just by way of introduction to everybody, my name is Ethan Donald, and I am the CEO of ExactFlat. I'm joined today by our application engineer, Keith McQuan. And we're going to take you through a little bit of an introduction to the features and functionality of ExactFlat. It'll probably be about 20, perhaps 25 minutes in total. It will be a relatively abbreviated high-level summary to give you a flavor for the capabilities of the technology and the benefits that you'll be able to derive from it. And I would highly encourage everybody to, if you have a question, throw it in the chat box on your GoToWebinar control panel, and we will be stopping periodically to take questions. And if we do run over a little bit, we're happy to do so in support of helping you guys get a better understanding of the opportunity. We got about 5 or 6 slides here just to get us sort of grounded in what we're going to do today. So Keith, if you want to just flip ahead to the next slide, please. In terms of why we are here today, the overarching reason why many people come and attend webinars such as these, and we do tend to give a lot of them these days, is in support of better design in less time with lower product development costs. Typically, if you're a technical stakeholder who's actually using SolidWorks today, or if you're a business stakeholder, perhaps an engineering manager or director who's in charge of a process, really you're looking at getting what you want to get done to a better level of quality in less time and with a lower development cost. Ultimately, there's somebody in your company who is interested in winning more business, and that business can be won at a higher profit. And if you're on the webinar today, then this is something that your customers will probably take note of in terms of your capabilities in bringing your products to market better than your competition. So that's kind of the main reason why we're here. We're going to focus today's webinar on the less time, and if you skip ahead to the next slide, please, Keith. There's really 5 process areas that are of particular interest for us today. We're going to talk about pattern creation, which is how do you create your initial pattern from a 3D CAD model, or if you've got a physical model, pattern engineering, nesting, getting your files out to production, and then the documentation process. We're not going to focus so much today on the costing. If anybody wants to know about the costing, I would encourage you to please reach out to Javelin. You can reach out to Eric directly, or you can reach out to our team. We work very well with Javelin, and we would be happy to take you through some of the aspects there. Now, if you want to skip ahead, please, Keith, again to the next slide. In terms of the time, we're going to really talk about how you can reduce key process time in these critical sort of process areas. The next thing we're going to talk about, the next slide please, is how to reduce the, next slide please Keith, is how to reduce the transit time. Whoops, you skipped one there. Is how to reduce the, if you can go back one please, is how to reduce the transit time between these processes. Now the reality today for many of you, and I'll say this without knowing exactly what you're doing today, is that you're typically using different processes and different technologies for these key steps. So you may have a nesting program, you may have a documentation program, you may have a pattern engineering, 2D CAD program, maybe AutoCAD or something from Gerber or Electra perhaps, and maybe a manual process for pattern creation. And in between these process areas, you have a transit, and we say transit in a manner in which it just signifies moving your work from one place to the next place. And it's a handoff from one team to another team. So this transit time and the wait time associated with it is it can be quite significant in bigger, more complex organizations. We're going to talk a little bit about that today in terms of how you can save time there. Next slide, Keith, if you would please. Ultimately, what we're looking at here is a scenario where your current process, which is shown sort of in the middle there, is replaced by a new process, and one which is characterized by a couple things. We've linked the different processes together, eliminating this the waiting time and the transit time, and we've shrunk the overall time and effort required to conduct the work from start to completion. So your process will look much leaner, much more efficient, much simpler, and you will eliminate a lot of the waiting time. And that's exactly what we're going to focus on today. So if anyone has any questions at all, again, I would encourage you to go ahead and drop your question in the chat box. Okay, we're almost there. So just next slide, Keith. We know that everybody's time is valuable. So in support of making the best use of your time, I would encourage you, we asked the question, why wait? If this is something where you are looking to get a better understanding of how these processes can change, why don't you go ahead and tell us how long it takes, tell us what your target area, your target percentage of improvement is, and send us a file. You can either send it to Javelin or you can send it to us at this team at ExactFlat. We'll be working on it together. And what we'll do is we'll process your file. We're going to record a video with a stopwatch to show you how long it takes. We're going to send you the result. And after you get the result, we can demonstrate in less than 45 minutes how your company can get results like this in your environment. So if this is what any of you require or any of you are interested in, please go ahead and reach out to Eric, and we will schedule something even as we're on the call right now. Okay, So with that being said, we're going to switch to live product view right now. And we're going to use this model of a car seat. And for those of you who have perhaps seen this on our website or who participated in other webinars that we conducted, this is a model that was modeled in SolidWorks. It was modeled as a surface body, but you can model it as a solid or you can model it as a surface. It really doesn't matter. And it's a representative model. This could be an inflatable structure, such as a bounce house or a tethered aerostat. We've got companies who are doing both of those things. It could be a fabric pulled over a frame, such as boat covers or a bimini or something like that. It could be a composite carbon fiber part that would be laid up into a mold. It could be a piece of fabric pulled over a softer surface, like a piece of foam, like in an upholstered furniture or things like that. Any industrial fabric that is used for industrial purposes is appropriate for ExactFlat. If it is a soft formed material, that is where you're going to get your tremendous time savings. For those of you who may be working with metals, there's a way that you can use ExactFlat for metals too. We're not going to cover that today, so if there are any of you out there, please do reach out to us. Now, we talked about saving time. So we have a CAD model here. The first thing we have to do is we have to get to our initial flat patterns. We're going to create our initial flat pattern. So what Keith is going to do is he's going to use a tool we call the piece creator. And you can see he's just selecting the faces on the CAD model. As he selects the faces, he clicks create piece, and it will knit and weld those faces together. The piece creator, once a piece is created, it will become transparent, and it's locked for editing, as you can see there. With the transparent pieces, the model will allow you to select through layers as well. So if you have a layered product, say for example, say an insulation blanket, a removable insulation blanket for a valve and piping system, you'll be able to select through those layers and manage multiple layers, like in a carbon fiber layup or other things. Okay, so once we've done that, we just click Convert to ExactFlat. And what ExactFlat is doing right now is it's going to index the locations of edges that are coincident to one another. So the left edge and the right edge, it's going to just make an index of all those. That will be very useful for later. The next thing we're prompted to do is to assign a material. In order to get an exact, accurate fitting flat pattern, we have to assign material. So this particular seat, we're just going to assign a leather to all the pieces. And then we go to our flattener view. And just noticing that there is a little bit of a lag on the screen here. We do experience this from time to time with GoToMeeting. So I'll try and slow things down, Keith, and if you can just pause momentarily so that everybody knows what is going on here. So the first part of our process is we're going to create a mesh, and while the mesh is being created, we can talk about what's happening here. So you can see we've got a 3D model on the left, we've got our flat patterns on the right, and we create an analysis mesh. The analysis mesh is a mesh which is optimized for the mathematics of the simulation. The simulation is going to take the 3D pieces and flatten them into optimized pieces. Now, we've got flattened pieces here, but they're not yet optimized. So we're just going to, Keith, if you can zoom in or just click on a panel or a face with some stress and strain on it, please. And you can see what the algorithm is doing is the algorithm is actually pinching away areas where there's excess material, and it is relaxing or adding material to areas that have strain, that are pulling tightly. And this is the optimization process, and it should take about, for parts of this complexity, maybe a minute or so. You can see that the optimization is complete. We've got a status there where Keith is just hovering his mouse over. And so now we have to update our pattern pieces. So let's just go ahead and click OK. We're rebuilding the geometry with the new edge associations that we created initially. And there it is. We just have to now update our geometry in SolidWorks. And we will, at the end of this process, have accurate flat patterns that typically would have taken you at least half a day if it's a part of this complexity, or even longer if it's a part of higher complexity. We're just going to do a quick layout here to put these pattern pieces in a layout which is going to be similar to how they're going to be sewn together. We have a simple little tool here. This is particularly helpful in saving time and effort because it will give you a very intuitive sense of how these pattern pieces go together. All you do is click the edge, and just click the edge. It'll find the adjacent pattern piece. And I am still noticing a screen lag, so just wanted to point that out to everybody. You click the edge and it'll find the pattern. You can see as Keith walks along the edge or runs his mouse along the edge, you can actually line the pattern piece up at a particular point. There we go. And now we have key process number 1, which was pattern creation completed. And that probably took us, I'll just say, under 5 minutes for a project of this complexity. Now the beauty of ExactFlat is that these patterns here, 99.99% of the time, they are going to be perfectly fitting parts. There are situations where it may not be perfectly fitting. For example, if you have fabrics under extremely high tension, so for example, the roof of Denver Airport, which is a fabricated roof that has extremely high tension cables pulling that roof into place. There's a little bit more you have to do to deal with projects like that. And if anybody wants to know, please do give us a call. We'd be happy to talk to you. But process number 1 is now complete. We're going to go to process number 2, which is pattern engineering. And pattern engineering involves, for many of you who are doing it, for the benefit of those who are not doing it, adding pattern features like seam allowances, notches, grain lines, things like that. And here the beauty is you just select the pattern edge, and the adjacent edge is automatically found. And you can see that it will link pieces together in the sewing direction. So that's the beauty there. And we don't have to go find these pieces. We don't have to manually associate them as you would in a 2D program like AutoCAD or Gerber or Electra. You actually get the associations, and this was part of the indexing process that we used before. So Keith put an 8mm join on here, and now we're going to put some alignment notches on. So there's a number of ways we can do alignment notches. We're going to do them in an automated way here. We can either specify by count, or we can specify by spacing between. So we're going to use specify by count right now. And let's just go across this edge and put maybe 5 or 6 notches in. Let's see what happens with 5 or 6 notches. We can also precision place notches manually by picking a point and having it found on the other point. And if anybody wants to see a demonstration of how that's done, we'd be happy to do so. But for now, we're going to continue on putting some seam allowances in here. And you can see literally it's selecting the edge. It automatically finds the neighboring edge and gives you a visual picture of what that's going to look like. And then when you finish that, you can put a notch chain on. So let's put a notch chain on here. And that's it. So we'll go ahead and do one more edge because I think it's probably pretty intuitive. You get the idea here. Now the seam types that Keith is pulling from are selected from a database. If the seam type that you need is not there, these are editable. You can configure as many or as few seam types as you want. You can have any type of join, so you can see there join with top stitch, join, half-inch pinch. There's a way that you can edit these as it's a one-time setup. It's very easy to do, but that way you can enforce company standards and make it very easy for your designers to select the right seam type on projects and enforce uniformity and not accidentally put a wrong seam type in there. Okay, so let's just put some notches on this final edge. And there you have it. We're not going to do the other half of the seam allowances because we're going to show you a little bit about revision control a little bit later on. But suffice to say, that's the picture of how you do your basic pattern engineering, and we do support other things like hems and bound edges and raw edges, as you can see in the toolbar at the top there. If you wanted to put hardware, we use SolidWorks sketch entities. If you wanted to put markings on there for locations, maybe where you have to sew reinforcement patches or things like that on, that's available as well. If there's drill holes or grain line editing, all that stuff you can do with the tools that you know using SolidWorks sketch entities, and those tools will make it possible for you to use the very specific things that you need to get your work done. Okay, Keith, why don't we now go to the nesting view? So I just want to stop here. This was the second process. So, you know, maybe this took us 5 minutes. Perhaps to do the whole thing here, it may take maybe 10 minutes, maybe 15 minutes if you're getting into very, very detailed pattern engineering. But Keith, why don't we go to the marker view now, please, if we could? This is the third part of our process, which is creating a nest. And you can see that our pieces are already laid out on our marker sheet. And you can see the little yellow line in there is the grain line. This is the default grain line that came with the selection of the leather material. So when we assigned the leather material, when we went through our flattening process, there's a number of things that happened. The first thing that happened was it assigned engineering properties that take into account the specific stretchiness of the fabric or material in question. If we assigned say a synthetic nylon, like a stretchy material, like a trampoline bed or something like that, that's designed to stretch, the flattening algorithms will give you a different result than if you assign, say, a carbon fiber, which is designed not to stretch in the direction of the fibers. Or, for example, a leather, which is not a very stretchy material to begin with compared to others. So the grain line was the other thing that was assigned, as well as piece gaps, edge buffers from the edge, and things like that. All the lay rules that came with the material were pre-populated as well. We can edit those, like piece gaps and edge buffers, and the nesting is full-featured. We can have a lot of constraints in terms of how we do the lay rules, like using bound surfaces or unbound surfaces. But for the purposes here, we're just going to go ahead and build a quick little nest. To do that, we just click the Nest button, and we can start the nest. So you can see the nesting algorithms, they take a couple seconds just to initialize, and then it'll start to pack down the nest as best it can. And you can set this nest to run for any length of time. We've got it to run for a minute. We may let it run for the full minute, but we may not. You can have it run overnight. You can batch jobs together. You can combine parts from selected jobs. So if you're doing this seat bottom, the seat back, and the headrest, you could have them nest all together. You can put those nested elements into groups, so you could have an easier sorting process. And you can see this is actually nesting on a bound surface. It's a sheet, so the yield here says 34%. That's because there's a lot of excess material. It's actually not giving you a yield on the nest itself. That's a configurable item. If anybody wants to know how you can find out what your exact yield on the nest is, I would encourage you to give us a call. We'd be happy to show you how. Okay, why don't we just go ahead and stop.
Real quick, you mentioned about batching jobs together. I know that that's a very significant thing for a number of industries. I think specifically you've been working a lot with the industrial insulation industry, where that's been helping out a number of clients there. I think that's quite common to have all these different jobs, smaller different installation covers, and batching them together. Is that fair to say that that's been helping that industry quite a bit, or?
Yeah, I mean, I'll give you some examples. So, for example, if you have reinforcing patches, you may have a standard size reinforcing patch, and rather than model your reinforcing patch on every single project, you make your reinforcing patch once. And I'm thinking, for example, in insulation covers where they would have reinforcing patches and strapping, or, for example, if you have in certain inflatables, for example, inflatable boats, they would have other reinforcing elements, or they would have elements where they have oarlocks or areas where they'd inflate the boat, or other things like that. So you model those things once, you keep them as a separate item in your database, and then when it comes to creating your product, you'll do your product design, and then you'll go into your database and add in your reinforcing patches or your other elements to your nest, and you will send them to the cutter. So this, again, is a very, very big time savings from having to model items which are used repetitively and over again. you don't have to model those items over and over again each time you do your work. You can just keep them as elements in the database, and away you go. In a car seat, for example, they may use tie downs like J hooks or little flaps and flanges or things like that. So yeah, it's a good point that you bring up, Eric.
Great, thanks for that.
Okay, so our nest is complete here. We're going to now just accept the nest. And this is the next part of our process where it saves a lot of time. So there's our nest. We're going to now go to export this nest. And as you can see, we can support to a variety of different cutters. We make presets that, for example, if you had an Eastman cutter, electric cutter, HP plotter, a Gerber cutter, for example, all these can be made as presets. And this, we don't have too many presets for this demo, but they can very easily be made. And our customers that have multiple cutters in their manufacturing environments, they may have a couple of Gerber cutters, a couple of electric cutters, maybe some Eastman cutters. They simply select the preset from the list, and then they click export. And this is the file that you would load into your cutter, and your cutter would take it from here. So Keith, why don't you just go ahead and open up that file. This is a layer DXF. It's to the ASTM standards. And there it is. And if we zoom in to the file, or maybe just put them side by side, we can see the difference. You can see that there's a couple of jagged edges in there. That's because we didn't put seam allowances all the way through. Right, but there's your nest file, and there's your nest file on your screen there. Now what I want to go back to is I want to point out a couple of things. So Keith, if you just stop here, for example, and I want you to switch back to the PowerPoint. Okay, just go back one slide. Yeah, so what we told you we do is we'd show you how we can reduce the process effort in each of these categories, and then reduce the time for transit and waiting in getting your work from one station to the next. We've covered pattern creation, which is the initial 3D to 2D flattening, basic pattern engineering, nesting, and production. And you can see that there was almost zero time between the different phases. If you go back to live view then, Keith, please. Okay, and just let's click out of the nesting environment. Now let's go back to our model view. So here's our model view, which is where we started the process. Let's go to our flattener view. And here's our flattener view. And what I'd like you to notice also is see how our flat patterns are now laid out differently from when we initially flattened them. This is because the different environments within ExactFlat are associative to one another. So changes made in one do reflect in the other. So let's click out of our flattener view, our flattener view, and let's go to our pattern view. And there it is. Now you can see that this is really where the beauty of the program comes in that all of these different process tasks are now embedded within the SolidWorks user interface. Your designs can be processed directly from SolidWorks, and this is where the speed really allows you to get things done a lot faster than what you're doing today. We have one more thing to cover, and that is our documentation. So Keith, if you want to just go into our document view very quickly, and we're only going to cover this at a high level as well. If you want to know more about this, I would encourage you to give us a call. So as Keith just gets a template there, the templates are configurable and editable. You can create templates based on your company standards and the purposes for which you are creating your documents, whether they be for design reviews or customer whitelists or cut lists or assembly instructions. That's really up to you to decide, but the templates do support all of those objectives. You can see as the documents, the flat patterns come in, all of our edge features are manifest in the document itself. If you make a change in your pattern view to any of those edge features are going to be then reflected back. The changes are going to be reflected back here. So let's go ahead and add some metadata in here. We've got three types of metadata which are automatically created. There's tables, there is balloons, and then there are callouts. So let's go ahead and put a couple of tables in, Keith. interface is very similar for those of you who are familiar with SolidWorks drawings.
And the beauty about this too, Eaton, is that Eaton, there was one thing you mentioned earlier on that's I think very significant, just as Keith is doing this, is the fact that it's all linked together, like associated together, not only helps with this one project, but helps with companies that have similar type of designs they repeat in the future. And I think that's, like a lot of the customers I've been working with, that ends up being one of the even more significant time savers, is being able to work from templates. So you envision like industrial insulation covering, for instance. You envision like a template elbow or a template T or a template type profile. And you just need to go and use the SolidWorks dimensions. You go stretch, push, and pull a couple seconds to go and change the new size of model, and all of your documentation can just be updated. You just have to go through the process, and it just is all associated. You don't have to reselect all the different stuff, as long as it's just a dimensional change and a size change, and not a significant different feature change. With different spouts, then it's you don't need to redo anything. So that's a huge time saver. And really for any industry, if you have different size. Another big one, we've been doing a lot of work with inflatables. So if you have different size. Take marine inflatable hulls as an example. If you have a different model lines that are made the same but just at different sizes, the work that you do at the beginning can be leveraged for those other sizes. It's just incredible time saver.
And in fact, Eric, we do have two of the, in fact, probably the two #1 brands in the world that are making custom hot air balloons. Think of like the Walt Disney Castle made into a balloon. There are one in the U.S., one in the UK that is using ExactFlat, and they're getting tremendous savings because of design automation. Reusable elements that you can either configure dimensionally, or reusable elements that are added to your model rather than having to model from scratch. If anybody wants to know, I mean, SolidWorks is the tool of choice for design automation. There's a whole universe of things that can speed up your production workflow, before you even get to the ExactFlat stage. But just to kind of round out back to the documentation here, you can see that Keith he's put in a number of tables with different information. Here's where you can start to give your team very clear, very concrete assembly instructions, or cut lists for vendors, or if you want to put an outsourcing pack for bid or things like that, or if you want to, or if you're bidding on a job for that matter. This is the way you can make use of the drawing and annotations, and you don't have to use a third-party tool. For many companies, they would go out to an AutoCAD, or they would go out to even Adobe Illustrator. All of this can be done natively inside the SolidWorks environment, and at a huge savings of time and effort. Okay, so that kind of runs you through the 5 process steps. We're just going to do one more thing. I know we're running a little bit over time, but Keith, I'd like you to go back into our pattern view, and what I want you to do is just add a couple of extra seam allowances, or maybe change the material. Yeah, let's change the material. Change the top piece of the material, or the center piece. It's up to you. So let's suppose this was maybe a cloth seat, and we wanted to, or it was a leather seat before, we wanted to change it to cloth. All the materials in the database would have a color designation. The color is only just to differentiate one material from another. It's not necessarily to have any necessary association with the actual material, although you could do that if you wanted to. And you can see that he just goes to change the material in the pattern view, and you can see there it's updated on our table, and visually it's updated in the document itself. We know that the design process rarely these days is linear from beginning to end. There's a lot of back and forth often as new information comes, new design criteria is introduced, new cost constraints are put on the project. Designers have innovative thoughts that will impact how the product is made or sold. All that stuff impacts the design process. So it is a back and forth process, and this gives you just a quick little window into when those changes happen, they propagate automatically in the ExactFlat environment. So that's the quick flyby. If Keith, if you want to go back, and again, if anybody's got any questions, I would encourage you to just drop them in the chat window. Just go, yeah, here we go. Okay, so what we had set out to do is show you how you can make better designs in less time with lower product development costs, ultimately leading to more business and higher profit. We really focus today on less time. For the other aspects, better design and lower development, there's much more we can talk about, and I would encourage you, if you have questions, to go ahead and reach out to us. If you just go to the next slide, Keith, in terms of how we achieve the less time, it is through the ExactFlat technology, and there's two primary areas that we targeted. One is the process time for your key tasks, pattern creation, engineering, nesting, production, and document creation. So we've tried to shrink the amount of effort required to do that. The second thing is in terms of the transit and the wait time between those different tasks. We have tried to essentially eliminate all the transit and wait time. Ultimately, this is going to lead to a scenario where you can get more done in less time. And to prove that to you, if you want to just go to the next slide, Keith, again, what we'd encourage you guys to do is if you tell us how long it takes you now and what your target for improvement is, and you know, if you don't have necessarily a target, we would say just tell us it's 50%, and we'll take that and go for it. And then you send us a file, we'll process it, record it with a stopwatch, send a result, and then demonstrate in probably about 45 minutes or less how you can get the same results at your company. So Eric, with that in mind, I think that that kind of wraps up the technology portion here. If anybody would like to reach out to us, here's the contact information. The ExactFlat team and the Javelin team are working very closely together, so you know, you may reach out to either of us, and we'll bring in the right resources to